Hi, in this video we are going to talk about decision trees, so let's get started. In a decision tree we have features as we have seen in all the machine learning algorithms. So for example, we have a data set like this, a temperature, humidity, whether it's windy or not, and the question is, will we be able to play tennis? And we have lots of data. For example, if the temperature is hot, the humidity is high, and it is windy, then we are not going to play tennis. But on the other hand, if the temperature is mild, the humidity is low, and it is not windy, then we will play tennis. And we have lots of data. And the aim of decision tree algorithm is that it is going to construct a tree-like structure for us, like this. So it is going to construct this tree such that now in this situation I left out humidity, I think. But the basic concept is that we have to construct a tree-like structure, and that's what Python is going to do for us. And of course we have a left child and a right child, and these edges are going to represent the options. For example, the temperature can be high and it can be low. The wind the weather can be windy and not windy, and so on. And the leaf nodes of this decision tree will be that whether we are playing or we don't play tennis. So this is our question usually. So after we have constructed this decision tree, we just have to traverse the tree according to the features. For example, we are going to train our decision tree, or other way, we are going to construct our decision tree according to the training set or the samples. And for example, we have another data and we want to make predictions. So if we have a high temperature and if it's windy, can we play tennis? And we are able to answer that question with the help of this decision tree. We just have to traverse it. We have to start at the root node, and the temperature is high because that's the feature. I mean, that's the temperature is high. So we go to the left. Does it windy? And yes, it is windy. So the question that do we play tennis is yes, we can play tennis. And this is how decision trees works in practice. If you are interested in how can we construct a binary, I mean a binary, it's kind of a binary search tree, but it is called a decision tree, and it is not so straightforward. So we have to know something about entropy, and that's why if you are interested in it, I think that most of data scientists are not interested in the low-level stuff. Most of my colleagues have no idea how support vector machine do in the background. They just know how to use it. But if you do interest the theoretical background of decision tree, and as far as I am concerned, I think it's very interesting, we can conclude that how can we calculate that what will be the root node, for example, what will be the next level layers, the nodes, what will be the leaf nodes, and so on. And we just have to know something about entropy. In physics it is called the Boltzmann entropy, but in computational theory it is called the Shannon entropy. And if you are familiar with cryptography, or for example Huffman encoding, it relies on the same principle, the Shannon entropy. So we just have to calculate the Shannon entropies with these kinds of formulas. It's nothing, it's no quantum mechanics. It's very easy equations, by the way. We just have to calculate it. We just have to calculate the information gain, and then we have a final equation. Yeah, there's the gain. Tx is equal to the entropy minus the entropy Tx, and with the help of this we can calculate that what will be the root node, because the root node will be the feature that contains the most information. And why is it good? Because at the beginning we can get rid of the half of the data. So it's very similar to the basic concept of binary search trees. Why is a binary search tree good? It is good because you can get rid of the half of the data at the first step. And this is why it's important to be able to construct a tree where the root node contains the most information. So It is the decision tree algorithm is a supervised learning technique for classification or regression. So we use it to two main algorithms, to two main types, if you want to classify something or to just use regression. We create a model that predicts the value of a target variable by learning simple decision rules inferred from the data features. The data features are the temperature, humidity, windy, and so on. It has several advantages as well as several disadvantages. So let's talk about the advantages. It is very simple to understand and to interpret what is decision trees about, and tree-like structures can be visualized. No need for data preparation such as normalization or dummy variables. So usually in machine learning, normalization means that we have to normalize, for example, the data. So we have a data set and we have to divide each of the elements with the highest value, for example, or we have to calculate the mean and standard deviation of the data, and we have to multiply or maybe we have to divide with the standard deviation and something like that. And that's why decision trees are very convenient, because we don't have to do anything like that. And because it has a tree-like structure, it has a logarithmic time complexity and logarithmic running time. So what are the disadvantages? Decision tree learners can create over-complex trees that do not generalize the data well. So these trees can get very, very complex. And this is the problem of overfitting. And maybe pruning sometimes helps, as I'm not sure whether you are familiar with, for example, Minimax algorithm or chess engines, but this is the same concept, that we have a tree-like structures with lots of leaves and lots of branches, and with the help of pruning we can get rid of lots of branch, and it's going to boost our algorithm. Decision trees can be unstable because small variations in the data might result in a completely different tree being generated. It's very important. And the problem of learning an optimal decision tree is known to be NP-complete, very, very hard. So practical decision tree learning algorithms are based on heuristic algorithms such as the greedy algorithm and so on. So there's lots of advantages as well as disadvantages of decision trees. That's for this video. Thanks for watching.